1, 2. Thank you, Colin. And good morning, everybody. Thank you for turning up. There's probably more seats around the middle here. If you can't see at the far end, if you'd like to migrate down here, it's up to you entirely. Okay. I'm quite surprised the room is so full. So either you've all got problems. If you've got any MC problem, put your hand up. Yeah, okay, right, okay. I could just say, if anybody doesn't put their hand up, then they're either asleep or not. And they have, but they just don't realise it. But let me just get my notes organised. Here we go. Okay. There's some repetition of previous talks. This is going bonkers. Whoops. Where is it? Right. There's some previous stuff I've taken from previous talks, so I hope I've spoken to the people concerned and doesn't appear to be, the thing is going bonkers here. EMC, mate. No, the mouse is going bonkers. What do I do? Yeah, it must be. Anyway, the screen's going all over the place, so this should be entertaining. Okay. This is what I'm going to talk about this morning is basically Vdsl, because everybody suffers from Vdsl. Time-lapse recording is a very powerful tool, and it can yield a lot of insight. Coming back to Vdsl briefly, if I may, if you're living within approximately 30 metres to 50 metres of a telephone line, you probably have it. If it's further than that, you'll be in the far field, so it's much less of an issue, but it's still quite likely. Now, if you're out in the country and you've got farms all around you, or fields, shall I say, if you beam towards the town, you'll hear EMC noise, so you'll hear VDSL noise. So it's all over the place, but it's the near field thing that you can really fix. You can't fix the far field stuff, unfortunately, very easily. Okay. So there is no magic fix. Okay, so what we have to do is find out what the issues are. Okay. It's a selection of issues here. There are a list as long as your arm of potential issues causing EMC problems and affecting your receivers. I just pick out one here, PLAs on 24/7. There's no filter inside them because if they put a filter on it, it wouldn't work. So the mains filter, or lack of one, means that PLAs are a distinct problem. And I know they're allegedly notched. I'll come on to that later on. Power line adapters, Ethernet over the mains cable, basically. These things you plug into the wall. And they can be heard into the very high bands as well, up to 10 and 12 meters. Wide and narrow band is a key point here, really. Is the QRM that you're seeing cover a wide band or a single frequency with respect to time? Television noise, if it's got an aerial plugged on it, remember those old things on the roof? Okay, if it's got an aerial plugged on it, but even if you're getting your TV via internet, the aerial itself acts as the radiator is nice vertically polarized, and it's about 10 meters tall, isn't it? 12 meters tall, and it couples into the TV systems, the time bases for the screen, the 60 kilohertz, quite nicely. So the old-fashioned high-pass filter works really well. Do you remember those things with a copper-clad board? You've got the old Dremel out, and you put that in the lead, and the noise drops. It can't guarantee it, of course, but it turns on the TV. Okay, is the noise domestic? Is it you? Is it your environment? Is it next door? Is it down the street? All of those things. Day and night obviously will tell you if it's a long way off. If you can see the difference at day and night, that could be it's a heating system, or it could be a propagation issue. It could be that it's emanating from a long, long way away. Okay, let me just get my notes organised. Whoops. Okay. VDSL2, it's probably not a good idea really, is it? It covers about 1.6-ish up to about 17 megs. Okay, it's not a good idea, really. Okay. You've seen this slide before 100 times, I'm sure. But it's divided into various uplinks and downlink bands. So if you look at that top bit of the slide there, you'll see the D2 band starts at 5.2 megs and finishes at 8.2. So D2 means it's a downlink frequency or downlink band. The U means it's an uplink frequency. Now clearly, down the phone line, you get different propagation properties down that twisted pair down at the D1 frequencies compared to the D3 frequencies. So the D3 frequencies won't go very far, whereas the D1 frequencies do go far. Or relatively speaking, anyway. Okay, I'm sure you've seen this slide as well. The reason I put this up again, because when I first saw this, I got quite confused about it. But if you look at our friend Mr. BT in his office block, there on the right-hand side there, you've got the cable, the fibre coming to the green box, and out of the green box, or adjacent to it, or in your garden, is either a pole like that with some wires coming off it, or it's underground. If it's a new property, it'll be underground. If it's an older property, it'll be overground. But they could be on the street that's 200 metres away. So that's what the network looks like. Okay. Has anybody actually checked for VDSL noise where they live? Hands up. You know. Okay. So the rest of you really need to check. And I'll show you how to do that. It's quite straightforward. Okay. I normally have a show of hands about who's got overhead and underground thing here. And anyway, but I'm sure. No, I won't bother with that bit. The graph here is downlink speed. Can you read the words on it, all right? Okay, that's downlink speed here. So 0 and 80 megabits per second, allegedly. Okay? And this is distance from the green box, i.e. that length from there to there. Okay? Or from up there to here. Okay, so at the lower frequencies here, or the lower distances, say you're 400 meters from the green box, you should be able to use the up 1, up 2, and D1, D2, D3 frequencies. That means you can use all of those in that spectrum down the bottom there. As you move further away, as you get to 1 kilometer, if you can read up from 1 kilometer, it's about 30 megabits per second, okay? In which case, you're using U1 and D1 and D2. So those using the low portions of the spectrum there. So clearly, if you're a long way from the box, 3 kilometers, in fact, I think this slide is a bit optimistic, to be honest. I think if you can get 10 megabits at 3 kilometers from a green box, you'll be lucky, I suspect. But you can see quite clearly here, as the frequency goes out, you're more concentrating on these frequencies here. You're probably not using that, because that's nearly DC. Whoops.
Is that also selected by the router in your house, according to what it's actually?
Well, it negotiates. I'll come on to that. Yeah. Right, next slide. Okay, this was when VDSL was first introduced. I thought, oh well, I'm all right. I can hear everything. It's not a problem. And then it really did get introduced where I live some years later. And this is done in 2015. And this is on the D1 band, so it's 80 meters, CW end. Can everybody see the slide all right? Can you see the resolution and the spikes on it? Okay, let me just get my pointer out. Unfortunately, it won't let me put a pointer. Ah, it will do. Okay, all right. So you've got frequencies there, 3.49 up to 3.59. So it's 100 kilohertz wide. Sorry, I've got to look at this screen and move the mouse. It's 100 kilohertz up there, and this is time down here, okay? So if you look closely at that, oh, by the way, this is taken with using the original version of SDR Sharp and a FunCube dongle, which is around here somewhere. So what you can see here, these spikes at the top spectrum there are the 4 kilohertz training sequences. And they were on for a given mark space ratio of, bring that back, okay, 19 to 7. So it was a mark for 19.7 and a space for 7 frequencies. Sorry, on for 19 and a space for 7 seconds. Okay, so if you look here, for example, just in here, the bright line, that period there is 19 seconds, and the off period was 7 seconds. And then it comes on again, then it goes off again, and it comes on again. This was the training sequence. Now, if you look closely, you can see the bumps in the spectrum here between the spikes. Can you see the bumps there? And lo and behold, if you look below that, you can see some modulation. Let's take that one there, for example. Okay? You can see 2 narrow lines in between those two carriers. And there's different patterns between the 2 carriers. What this means is the training sequence is not just plain carriers. Each one is modulated to some degree with a fixed pattern. Okay? And the pattern is the straight line, of course. So there's modulation on that, which is interpreted by the other end of the network as to which frequencies are good and bad. Okay. How long does it take? In this case, it took about 3 days to recover when I eventually worked out what was happening. So I kept tuning across the band and hearing these big carriers, and I think, all these Italians all over the place, you know. Couldn't believe it. And then the penny dropped, you know. So it's basically low data rate modulation with a fixed pattern. And every one is slightly different, okay? Clearly, that one there has actually got a carrier behind it because you've got some data in the silence period, effectively, okay? But you can see a different pattern between that one. That's got none at all between it. So there's a lot of negotiation going on with Mr. BT when it goes through these training sequences. Does anybody here actually experience training sequences still? Because whatever I try and do now, I can no longer recreate this. However, the noise is still there. I'll come on to that. Okay, so that's what it looks like on D1. Okay, and we come into the top end of 80. This gets interesting. So, top end of 80 there, that's 3.6 up to 3.7 something or other. 3.8, okay? If you look here, this is what they call a guard band, where there should be no Vdsl noise. But what you've got here is the telltale signs that we saw before. Whoops, I'm putting the cursor on here and it's not working because I need to... Unfortunately, I can't the system won't let you put the pointer on here and the zoom at the same time, which is really annoying.
You had the cursor on just there.
Sorry?
You had the cursor on just there.
Yes. Yeah, I've got to send it that way, so it's sort of back to front. Okay, right, there we are. So those are the areas, and that's the modulation associated with that particular training sequence. Hence the word training, because it's trying to work it out, and a plain carrier conveys no information. So you can see the noise burst there, but it's all a bit messy. And what you've actually got into the uplink band is this other stuff, and that's behind that. Okay, so you've got a second system overlaying the first system here, which occupies the same frequencies at the same time. Now, it could be, of course, one is coming from over there, and the other one is coming from over there. I can't rotate my 80-meter dipole very easily, you know. So it's possibly 2 systems, but if anybody knows what that is, I'd be really interested to find out. But I've not been able to find out what that is. Bring the cursor back. Right. Okay, here we go again. D3. Okay, you've got exactly the same problem here, and the carriers are again evident there. Whoops. The top and the noise bands there, particularly prominent there. Okay, so that's there for days and days it used to be. Okay, and I'll give you one guess what that band is. All that modulation. Yeah. Okay, people have asked me, well, why is the line straight like that and all that fuzzy stuff around it in the waterfall? It's because 90% of the energy is in the actual carrier, and only about 10% is in the modulation when it's in training mode. So it's a very low duty cycle, but high rate duty cycle. That's why it's getting that picture like that. Okay, from what I recall, I think the total power they allowed is about plus 23 dBm. Over the whole spectrum. If I'm wrong, my apologies, but I think that's what it is. Okay. This next slide I borrowed from the RSGB. I'm sure they wouldn't mind, but it is a really good document it's come from. The EMC 15 leaflet. Now, I thoroughly recommend that to you. It's very well written, and it conveys an awful lot of useful information. So I borrowed these pictures from that to show somebody who's seriously got a problem. I've put the bands at the top of the screen there, as you can see. So that one there, for example, is the D2 band. So that's the downlink from the exchange to him. Oh, and this is a 10 dB step, by the way. Oh, let's put the cursor on. Sorry. Why is that not working? Laser pointer. Okay. That's a 10 dB step there. Okay. That is a 15 dB step. These are the guard bands down here where there's a swap over. So that point there is 8.5 megs. And if I, whoops. If I do that dip that you can see there is 8.5. Now, if you try and look for that without an SDL, without a waterfall display, you're wasting your time, to be honest. It's a real struggle. So you need something with a waterfall display to be able to see this sort of stuff. Okay.
Because it's on an exact frequency, you can tune to it and find it.
What you'll find is the gaps actually are not consistent. They do move around, from what I've discovered anyway. They appear, the window that you get seems to do that.
There are
From
two different systems that use two different
oh, okay.
things.
All right, John.
Apart from that,
Yeah.
two crystal things.
Well, yeah, that's for 4.3, but the actual, the band edges, I thought, changed slightly. Not much, a few kilohertz, maybe 10 kilohertz, I think. It could be that that end block is not being used at that location, of course.
Or it could be a real signal.
Could be. Yeah. Right. This is interesting here. Why is... Let's put that up. That D1 only half used. Why is it only half used for that downlink? So all that low frequency stuff from 138 kilohertz all the way up to about 2.2 megs is not used. Any ideas? Oh, that's cheating, John.
It's because the training found that it couldn't get through.
I have another solution, another suggestion. You could well be right. It could well be ADSL, because that has to coexist in the same adjacent cable, and they don't like the crosstalk issues. So that's another possibility. Okay, moving on. GFast was the the attempt to get hyper-fast broadband down bits of copper. And it was originally documented to start at 19 or 21, up to about 106 or 212 megs. Can you imagine trying to squirt 212 megs down a bit of telephone cable? So anyway, notches are in the spec, but not mandated. Trials, as it says there, if you live very close to the box, it was lightning fast. If you live very far away, if you live more than 300 or 400 meters away, it was marginal at the best. Anyway, BT have abandoned that, or should I say they've, to my understanding, have stopped expanding the G-Fast network. Is that right, John? No. Okay, oh, my apologies.
It's going slower than they wanted it to.
Yes, yeah. Originally, I believe there's about 3 million users on it, apparently. From what I recall, there was about 10 million planned, but I'm not quite sure about that now. Anyway, moving on. Somebody asked me what a green box looks like. So, if you're in the audience, this is for you. They do come in different types and sizes. In fact, I saw a lovely one in one of the articles on the internet where in a little village they were complaining about this green box being an eyesore, and it was behind a lovely stone wall, this big green box sticking out. So they painted it with stones. And now you can't see it at all. But anyway, digressing. Overhead lines nearby. Okay, you probably have an issue of some sort. Uplink, that means from you, the consumer, to the exchange. Power is backed off depending on the distance you are to help reduce crosstalk on the adjacent lines so that you get the speed up. System imbalances. There's bound to be a high VSW at some point because you're trying to match the system from DC to practically 17 megs, and it's quite difficult. So there's going to be points where there's going to be a mismatch at your end, and there's going to be high and low loads along the line at various points, and so they will radiate.
Is the system now obsolete in terms of BT going over to fibre, full fibre network?
VT, as far as I'm aware, BT are... Sorry? Oh, sorry. Say the question again.
I'm thinking that Vdsl is going to be, will be obsolete.
Will VDSL be obsolete? I'm not sure it will because of the market. You know, I mean, who's got it? I've got it. You know, it's on all of the cable networks. It's on all of the... So I don't think it'll be obsolete in the next 20 years. John might know better, you know. Because it's going to take a long time to get the fibre out, isn't it?
Vdsl is now rolled out to 25 million subscribers. It'll take a while to get them off. G.fast, which is called ultra-fast broadband, is being rolled out, and it will eventually pick up all of the old VDSL because it's a much better technology for them. Fibre to the cabinet is coming in, and it will solve our problems when it happens.
You mean fibre to the premises, do you?
Sorry, I did.
Yeah, okay, yes. Okay, so you're going to get radiation from these lines, be it from the domestic property, from the actual overhead lines. You tend to get more from the overhead lines because they're in free space. If it's in a building, they're surrounded by concrete, unless it's wood. Okay. If you've got spurs on your socket, try and avoid those. Now, one way of getting around that is to, on your master socket or whatever it is if that's a spur that's no longer used from the old telephone days, you can actually open circuit that there, and you take the feed up there to the spur and bring it back down again. Okay. So if this is your 5E box, the signal goes straight up there and straight down again. If it's the other side, on the data side, and you shouldn't have a spur on it, by the way. If you do, the same thing applies.
There's a better solution, which I invoked, because I was blanking out my router with it on 80.
Okay, wait a minute.
So
Is
It's
this
on, yes.
Yeah, David M0VTG. I was blanking out 80 metres, with 80 metres on a Sunday morning when I was trying to look at Hack Green as well, because I couldn't hear one end. But my router kept crashing, and I thought, what's going on here? And I realised that having had the house, when it was being built, flood wired for phones in every room, that there was so much antenna wire in there that it was just knocking out the router. So I scrapped the whole thing, put the router immediately on the end of which it wasn't on the master socket, and bought some wireless phones. Solved the problem immediately.
Yep. Okay, thanks. Okay, I've written down here, place master modem sockets close to the master socket. If you must use Ethernet cables, then use the Cat6 screened if you can, screened and shielded. Really cheap, recommend them. And then everybody says, well, the Cat5 will go up to 302 or 250 megs, what's the problem? That's true, but that's only the data rate. Doesn't concern about leakage. The Cat specification is about the performance, not about of the data stream, not about how it's made, and not about the shielding. It's about what data rate you can get and stuff like that. Okay. Right. Okay. I can thoroughly recommend a pair of media converters, by the way, and run fibre to the shack, which is what I do, and it works really well. Okay. Other noise sources. There are so many. What do? You need to understand what's going on. And because each time you turn the radio on, what's that bloody noise? And something's drifting in and out. And something got very weak all of a sudden. What's going on here? Okay. You need some toys to help you with this exercise. The SDR play box up there, which is around this. Oh, here it is, right in front of me. This thing, £200, great investment. I'll give you 10 megs of bandwidth to be able to look at. The FunCube dongle will give you 192. This thing will give you about 3 or 4 kilohertz of audio to look at or to listen to. So you can see here, to find out what's going on, when you start with the high bandwidth stuff, moving down to the... But you can use the SDR play, obviously, at the lower data rates, and just as well. Okay. So all these are toys to help you. The loop works really well because this one, for example, will do 30 to 60 megs quite easily. And the beauty about these is you can get a null on them. And the null works out really well because I know that exactly that null is so narrow. Okay, if you try and tune on a peak, it's that wide. So you can't tell where it's coming from. But if you can null it out, just like, oh, it's over there. So you've worked out exactly it is within a few degrees. You don't need these multi-element things. It's wideband. It doesn't look too obtrusive. You won't get arrested for carrying this, you know. unless it's a top band one, you know. Okay. I've written down here, the BY lamps. This is a Chinese LED lamp that I bought rather foolishly. And I thought it failed, so I had a look inside, and there's a filter capacitor missing. Oh, that was after it failed, by the way. Now, these are usually quite reliable. These are the genuine article, these, okay? But we've all lost them in the past, haven't we? We've all gone to eBay to buy some. This one is quite relatively noisy. This one is 30 dBs quieter than this one, okay? A phone charger, sorry. Sorry. Sorry, the sockets. Oh yes, yeah, the ones that we got in the hotel rooms. Yes, yeah. I don't know. I've not tested those, but I suspect they're rubbishy ones because everything's designed to a cost now. And when you move into a property or something like that, and it's got those fitted, you know, my heart would sink. But there you go. Now, yeah. This makes a nice aerial, wouldn't it? 6 meters. Okay. So what you want to avoid is, I've just used this as an example. If you've got a noise source here and you've got a long wire attached to it, it will radiate. It will radiate predominantly at these frequencies that are subharmonics of this distance. Okay. So if I tune that radio to this switcher in here, and I plug that in, and it doesn't get worse, it means this isn't radiating. Okay, so I can take that off, it's not of any effect. That means this is not radiating, that's a bonus. Okay. If I turn this radio on, I haven't charged this up now, but if I turn this radio on here, which is another tool I use, okay, at about 3 megs, and I put the aerial, this aerial, on this connector, does it get really loud? Or on this connector, does it get really loud? Yes. If it does, it's radiating down the mains cable. It's going down the mains cable. Potentially. That's all that. Okay. Next thing. Time-lapse recording. Really, really useful, powerful technique. I know I keep going on about this, but you can learn so much from it. Common sources and signatures that you can see. Modulation profiles, stop times. Transients can cause a problem, so you must use trace averaging. But you need very low speed waterfall. I'm talking about 24 hours for an A4 sheet, effectively, or one screen for your laptop. There's only one program I've found out that can do that, and that's HDSDR. There may be others that I'm unaware of. But you can actually go to 48 hours on a screen, which is really good for that. Okay, what does it look like? Now, this is a chopped screen from HDSDR. This is by Dave and K7Z. I put this up because this is what inspired me to check using his principles. This is a display of 3.5 megs to 4 megs, and it's 2200 local time at the top, and it's 24 hours, so it's 2200 at the bottom. And you can see there, whoops, what is it? There, it says midday. I've put that in here. Okay, these are every 20 kilohertz here. Okay, you can see something's happening at this point here, where it was dark, and suddenly it's become very light here. Something is happening, and that's covering that frequency there, which I can't read at the moment. Anyway, it's starting about here and going all the way up, and it seems to stop there, and then something else happens here. You can see where it's going from dark to light. Is that coming across on the... So you can see the different contrast. Okay, that's excellent, good. Right. If you look really closely here, in this area, and I'll put the magnifier on. Okay. You can see something here is starting with a little tail on it that's going all the way down there. You see that? Okay, something's switching on at 1 o'clock in the morning, that is, at that point there. That's 1 o'clock in the morning. Okay, and this is 7:30 in the morning here. This is, again, is quite interesting, this one here. So let's come off the magnifier. So something at that point is doing all of that. Okay? And then you've got all these other things here. That thing there being repeated there and repeated there and repeated there. You're not interested too much in these fixed lines here that you see here because they're on a single frequency, and you can quite easily work the DX on either side of that. It's not covering a blanket problem or a drifting noisy power supply that's all over the place, you know. So those shown every 20 kilohertz clearly are drifting all over the place. So they're a potential problem, but you could live with those. But this thing here means your ultimate noise floor is not achievable. Okay. Likewise down here you've got the same problem here. Okay, moving on. This is 40 meters. Again, that's midday there, and you can see all this stuff here, all this noise. Okay. Right. This is my location. When I recorded this, I didn't record it correctly, so it hasn't cramped up particularly well. But you can see here, this is 80 meters. You can see a lot of stuff in there. There's some individual sprogs with 100 kilohertz bandwidth. You can see all these spikes down here. That's the Met Office transmissions at the bottom end of 80. Right. This down here is probably overload of the SDR, of my SDR, I should say. Now, when you're taking these readings, care is really needed because you spend 24 hours getting all this data and then you do something, you lose it all. It's really frustrating. So if you're going to go down this route, please get to know the software, its limitations first. Don't wait 24 hours and then try and work out how to save it, because you only got one mistake and the whole video file is gone. So, word of warning. Okay. This is again at my place. It's just an hour on 40 meters. And you can see the actual discrete tone, not discrete tone, you can see the modulation bands there. Are they coming across? You can see at this end as well. Everybody see those? Just? Okay. And it gets worse. That's 30 meters. Again, an overload at this point at my place here. I don't know what that is. Could be some radar or something. But again, the telltale Vdsl is there. What notes have I written here? Okay. Yes. 5 minutes. Oh, crikey. More noise on the left on 20 meters. This is 20 meters again. Central heating stuff, which I've managed. That was my central heating, by the way, and I've sorted that out. I just managed to scrape the paint off the covering and line the bottom of it with tin foil, and it's fine, because it was the plastic underneath it. All this stuff is, not all of it, a lot of this has been cleaned up now at my place. 17 meters, okay, no VDSL noise. However, I've swapped that for 28 kilohertz stuff from my next door neighbour's central heating boiler. I can tell that distinctly because when I use this and I go next to the wall where his central heating exhaust is, it goes bonkers. But no VDSL tones, which is good. 15 meters, some 60 kilohertz, more 28 kilohertz, obviously, a bit of a problem there. And it goes on and on, 15 meters, there's the stuff there. Again, this is 24 hours. So this is quite interesting here. This is PLT on the left-hand side here, okay? And this is, like I say, 22 hours here. It's doing a resync at this point here in time, and that was 1 o'clock in the morning, midnight-ish. But it spreads right across the whole spectrum here. I left it running overnight. I don't know what happened here in the morning. I think I must have hit the mouse and the frequency changed slightly, so ignore that. Okay, QRM hunt, 14 to 20. This is an example, a unique signature I discovered covering 20 up to 10 meters. But I also found it weakly on 50 megs, and it turned out to be a Wi-Fi router in the local council offices where they had a tea shop. So I banged on the door and said, "Oi, what can we do about this?" And the manager there was quite helpful. He said, "Well, why don't I take that and put it in the back of the building and swap it for another one?" Okay, job done. So it was fixed. So that worked really well. So harmonics are your friend. Okay, in the shack, these are very good because they're gold plated and you've got low contact resistance, which means the signals don't radiate, whereas all these cables here, these USB cables, are rubbish. Because when you plug them in, you can't get a proper decent connection. So anything on there does radiate. It really does. So, and if you want to come up here and measure them, by all means, you can see this one is a 232 adapter. The actual outer is not connected to anything. Pin 5 is, but the outer isn't. The other thing I wanted to pass around quickly, I won't. Okay, what's wrong with this? Just have a quick look, pass it round, see what you think is wrong with it. You've got 2 minutes. Okay. Okay, avoid antennas into the shack because obviously it picks up local noise. Use balanced antennas or remote ATU. Vertical antennas away from buildings and metalwork. Common mode chokes. Here's one, I'm sure you've all used these. Noise cancellation, I won't bother going into that, but you all know what they do. Wideband loops are okay. Get the best earth you can. Now, I use these things. Not one, not two, but 3 of them, one on top of the other. And I've got 2 of them down at the moment. So they go down about 4 meters. And it seems to work quite well. Decouple all external lines into the shack. Like I said, I've got no electrical connection into the shack apart from the mains. So no Wi-Fi because it's all fibre. No telephone. Apart from that, that's my own. Okay. Next thing, we're coming on to some of these cores again. How to measure them using a network analyzer, VNA, sorry. And thanks to Ian and our friend Steve, unfortunately he's no longer with us, but he managed to get the equations out, and this is what you do when you plot the phase and amplitude performance on S parameters of this device here. Okay, moving on rapidly. I really must get this finished. Okay, clear point is that you want to be operating at some point where the ratio of resistance to reactance is low. So ideally, it's about 9 megs is where the thing performs best. Okay, but when you load it up, when you start adding extra things on the end of this, as you do, you put an aerial at this end and you put a load of coax at that end, the resonant frequency will shift somewhat. It will shift down. So I wouldn't use this above 17 or maybe 15 megs because it's this spike here that you want to be in, that area there. So maybe 5 to 14 megs would be ideal. Okay, noise on the HF bands, get a mains filter. Here's one. Here's another one here, coupled with your earth to help isolate the noise from the mains for you. Don't disconnect the earth line unless you've got an electrician in to put a separate earth in for yourself. Radio systems are designed for antennas that are designed to make the antenna work, not designed for getting rid of noise out of your earth system. So, out of time. Okay, right. Well, there's a filter there. There's a mains plug. It goes through there. You can put a choke in series there. In fact, the board suppliers, the manufacturers, quote, if you get RF interference, put one of these in from radio sources who make these alarm panels, the ones that we set off, you know those. They're about £12 each. You can make your own choke. You can buy this box here on Amazon for 30 quid or 40 quid. It's got a choke in it. It's got all that stuff. This is a wonderful filter. It's a bit pricey, but it's a double stage thing. I've got the spec for it. This is really what's important. This is really 2 minutes, I'm sorry. Is anybody in a hurry to go to lunch? No, see. Right. This is the wall of my shack here. Okay. It's a bit complicated, this drawing, but bear with me. This is the wall of my shack. These are the earth rods. So 1, 2, 3, 4 section there. 1, 2, 3, 4 section there. A couple of meters apart. Big fat copper pipe through the wall. Another big fat copper pipe up and down the wall. Okay, all these words here are attached to this. That's just to indicate they're all bonded together. Okay, so antennas outside, wideband choke have we discussed here. Another choke here, interestingly, at the input to the earthing point. That's to get rid of or to prevent current flowing down here. Any current that flows down here that you're picking up is then impressed on here, which in turn gets on the radio. Okay, it's on the earth line, but you've got to imagine this as an attenuator. Okay, so signals are coming on here. Here's a resistor here. Okay, and here's a ground, which means that resistor there reduces the voltage or the current flowing in that point there. If you take that away, any current that's imposed on there is imposed on your earth system. Okay, so you're isolating the coax, even though it's still connected. You're putting a resistor in series with the braid, effectively, you know, in RF speak. You must ground everything you can find, including the PC, network switches. Oh, avoid plastic boxes, 50 meg clocks inside which get everywhere. Make sure your router has got a plastic box, a metal box, I beg your pardon, and metal connectors here. Make sure the metal connectors are actually connected to the ground plane. And I'll come back to this one here. Use Cat6 or something that's got a metal bit on the connector, because that grounds properly there, and you don't lose all your screening. Right, rotator cables as well. Everything has to be grounded. People always ask me about upstairs shacks. You've got a problem really here, because this length is quite long. So you've got to get inductance down. There's two ways I know of doing that. How effective they are, I don't know. You go to Screwfix or BMW or Home Base, whatever it is, and you buy this aluminium strip foil that you put in the loft. Okay? It's plastic, it's 19 layers thick. You hopefully, if you can connect to that, it's £30, and you could drop a big long strip of it down the wall. Okay? I don't know how you could connect to it, I don't know how weatherproof it will be, but that's a possibility. Questions?
What was that website again for a 24-hour run?
24. I just put in that call sign. N7. I've got the list here. It's NK17net. You can see there's flashing here. My mouse is flashing in sympathy. It's going all over the place.
I can see we've got a lot of interest and potentially a lot of questions. Can I just ask, those who would like to leave, you've got 3 minutes to get out of the room, and those who want to carry on talking can carry on talking.
Okay.
Thanks ever so much. It's
One
been a
question here.
fascinating talk.
What's the number one question I'd like you to take away? Get a good earth. Thank you very much.
Wonderful talk.